Okay, let's have a look here. Verify that Z satisfies that cubic. Okay. That looks like a bit of a pain, doesn't it? All right, let's check it out. Okay. 2 minus 3i cubed minus 2. Oh, actually, do you know what? It's going to work out just fine because they did something very nice for us. Plus 2 minus 3i minus 2 plus 3i. So that will equal 2 minus 3i cubed minus 2 minus 3i cubed plus 2 minus 2 minus 3i plus 3i, and you can see that everything cancels out there. So, okay, nice. I was a bit worried about that one. Right. Now, B part seems to be cut out from this for some reason. Let me just have a quick check that I cut it out for a good reason. So this is 2012. And maths paper. Maths paper 1 project maths. Okay, let's see. Oh, that's not quite right. One moment, please. Sorry. I just want to make sure I'm not missing something for you. I'm just confused about why I have the B part missing. Usually the complex number questions, they don't mix in other stuff. For this particular question, part B was a matrix question. Yeah, so that's why I cut it out. Okay, so that's fine. Okay, so part C then. We want to solve this complex number. So I think we could write it in polar form. Let's make a bit more space here. So in polar form, it would be in the first quadrant. Okay, so the OR, which is the modulus of Z, that's the square root of this squared, the real component plus the imaginary component. Okay, that's nice, that's equal to 1. And then tan theta is root 3 over 2 over 1 over 2. So that makes theta tan inverse root 3, 60 degrees. Okay, so the equation is Z squared equals OR, which is 1, cos 60 plus I sine 60 then. Cos 60 and then I sine 60. In general polar form, you get Z squared equals cos 60 plus 360n plus I sine 60 plus 360n. You can put power a half on both sides, so you get Z equals cos 60 plus 360n plus I sine 60 plus 360n, power a half. And the Morphem says that powers multiply the angle, so that goes over a half then. So the two answers is first you put in n is 0 and then you put in n is 1. So when n is 0, you'll get root 3 over 2 plus a half I. And then when you put in the second answer, when n is 1, you'll get minus root 3 over 2 minus 1 over 2i. Okay, that's grand. On the Argand diagram, the point minus z, z squared plus k are collinear. Find the value of k. And I don't think the z is referring to this particular z here. So, okay, let's have a look at that one now. Right. So let's just put z somewhere generically. Imaginary axis, real axis. We'll just put it here, z. So minus z, that would be on the opposite side here, like that. And we know that they have to be at the same height because only the real component, oh sorry, my mistake. You minus the real and the imaginary, so it gets flipped down to here. Like that then. Okay. So whatever this length is here, it'll be the same on this side, and whatever height this is here, it'll be the same on this side here. So this is a 45-degree line. Perfectly 45 degrees. Now, the z squared plus k then, that's going to be somewhere here. Collinear means they're all on the same line. This is an interesting question. I'm starting to wonder if using the previous answer would have helped us, although I don't have it. I cleared it off now, didn't I? I'll have to get it back. So I had to go back in time because I realized actually the z here does refer to the previous question because z and minus z are actually the two roots to this one here. So yeah, it does refer to the previous one. Now, that's it here. They're the two z's, so to speak. Now, I really have a strong intuition that the k is 0. Because if you look at what I drew a moment ago, it seems like the z and minus z, they can be swapped around arbitrarily. It doesn't affect anything because, you know, you could call this one z and this minus z or vice versa. So the z and minus z, they're completely arbitrary which way around. You could have put them here like z and minus z. And flipping the sign on the z doesn't change this guy because the z gets squared. So I feel like this should not be affected as well by the choices of z and minus z. So I kind of feel like it has to be here. So I feel like the k not should be 0, but should be minus a half. Because you just wanted to cross the axis. But, well, no, that doesn't sound right now that I'm talking about out loud. But anyways, let's see what happens for the k. I think this question is quite interesting and quite difficult. So let me just copy the box here. And, or, well, no, you know what, maybe I'll just make space by erasing. I don't know. I really don't know what the k is going to be. At first I thought it was going to be 0, and then I thought it was going to be minus a half, but now I'm not even sure about that. So this is honestly going to be a surprise for me as well. So let's see what happens. Okay. So we have z equals root 3 over 2 plus a half I minus z equals minus root 3 over 2 minus a half I, and then z squared plus k equals a half plus k plus root 3 over 2i. And they're supposed to be collinear. So there's z, there's minus z. And somewhere on this line, perhaps in the middle somewhere, or perhaps further out actually, but somewhere on this line, there's a z squared plus k. And I think the best way to look at this is perhaps with slopes maybe, that the slope from minus z to z squared plus k and the slope from z squared plus k to z, they should be the same. So if you look at rise over run here and rise over run here, that should be the same. Okay, so what's the height here? That's a half plus k, and this is minus root 3 over 2. So it's a half plus k plus root 3 over 2 over, oh sorry, that's not the height, that's the height here is root 3 over 2, and then the height here is a half, so root 3 over 2 plus a half over, and then this length here is a half plus k, and then this length here is root 3 over 2. Okay, this one here now, that height is a half I, and we just want to take away, okay, so that'd be a half minus root 3 over 2, and then this one here, well, out to there is root 3 over 2, and then you'd want to take away this here, which is a half plus k. Ooh, that looks quite the mess to solve, doesn't it? But if we solve it, we get k. All right. They're conjugates, and they're okay, so it might not be too bad. So if I cross multiply, maybe I should get rid of the 2's first. So multiply everything by 2. So I have root 3 plus 1 over 1 minus root 3 equals 2k plus root 3 plus 1 over root 3 minus 1 minus 2k. Ooh. Okay, let's cross multiply. So we get root 3 by root 3 is 3. Root 3 by root 3 is 3. Root 3 by minus 1 is minus root 3 minus 2 root 3k plus root 3 minus 1 minus 2k equals 2k plus root 3 plus 1 minus 2 root 3k minus 3 minus root 3. Let's do some cancelling. That cancels with that. That cancels with that. What am I left with now? So on the left, 3 minus 1 is 2. Oh, that cancels with that. 3 minus 1 is 2. 2 minus 2 root k equals 2k. And then 1 minus root 3 minus 2. So I get 4k equals 4. So, okay, not 0 and not a half. K apparently is 1. Okay. Okay, that's very interesting. Yeah, there must be some other way to do this that it didn't occur to me. I kind of feel like I did it the hard way, but I got an answer in the end. In fact, I could check the answer. But anyways, this video has gone on too long. I'm just quite amazed by that last question. I'm sure there's some really smart way to do it that I'm not thinking of right now. But anyways, it'll have to do like this for the moment. Perhaps I'll re-upload this if I think of a smarter way to do it.